All right, awesome. Welcome, everybody. I'm excited about this, and I think we should jump straight into it. So the first thing, so what I'm really going to be looking at today is not just Docker specifically, but container technologies. So a lot of the time, these two words are used interchangeably, but they stand on they are totally two different things, and it's important to strike the difference between the two. Okay, so among the questions that I hope to answer today, these are just a few that I've sampled. So this is not a table of contents, but rather just a summary of the things that I hope to address as we go along. So there's a lot more, obviously, that I'll be covering, but these are some of the important ones. So the first one being, what is a Linux container? There's a lot of definitions out there just around what a Linux container is, but we'll take a look at that. What is Docker, which I'll also take a look at. What is a container image, which is also something that is different from a container. And I'll also talk a bit about container registries. Most importantly, we'll take a look at how to use containers in an interactive live demo. And the last part is why you should care about this. Hopefully, as we go along, you'll be getting this question answered. But if by the end, there's still more things to cover on that subject, I'm more than willing to take a look at that. So first things first, what is a container? And before we actually look at what it is, I'd just like to first take a look at what it is not, because there's a lot of explanations out there regarding what a container is. A lot of people like to use the analogy of a shipping container with good reason, but I think there's a lot, there's a different approach we can take here to make this easy to understand. So the first thing is that a container is not a Docker. I've actually seen an article on the web, someone saying, so, you know, for ease of deployment, you can just package a Docker and ship it. So it's important to get the terminology correct. Docker is a runtime engine that can run Linux containers. So a container is not Docker. And there is actually a lot of other runtime engines out there. For instance, CoreOS has one called Rocket, if I remember correctly, and there's another one called Runc. There's a lot of them. So, and some of these things coexist in the open source space, but it's because Docker popularized containers for most of us, it's easy to confuse the two. Also, I've been told in my early days of Docker that, yeah, it's like a lightweight VM, right? And if you think about it in terms of just creating that analogy or a picture in someone's head, a lot of people can look at Docker, at a Docker container or a Linux container as being similar to a VM. But it's not a comparison that I'm fond of. Because I have actually gotten hurt trying to imagine a container as a VM. For instance, you start thinking that anything that you can do on a server or on a machine, you can do inside the container. At one point, I tried to install SSH inside the container so that I can SSH into it. All things that are possible, but are not a good idea in the context of containers. And I'll explain why that is. And then the last one is that I believe personally that the container is sort of unfortunately named because now a lot of us take this and we use it in an analogy of, you know, shipping containers where you just package everything inside and you can deploy it and you can ship it to other places in a portable way. And it's for me, it doesn't really define what a container is. And you have to look a little bit deeper to really understand what a container is and how to set it apart from other technologies that exist alongside containers. And that's also part of what we are going to look at. So what really is a container? So a container, according to me, is really just a well-guarded process. Just like any other process on your machine, whether you're running Google Chrome or you're running Internet Explorer, whatever software you are running will have a process that is assigned to it. And as soon as that process is killed or it dies, everything goes away. So that's the end of the lifetime of that process. And it's the similar story with the container. Even though containers, I said well-guarded process because what makes it a container is the fact there's a lot of rules that have been applied around this process to make it special. So there are things called namespaces, things called capabilities that basically define what a container or what a process can or cannot do. There are C groups, which basically define what type of resources it can have access to, and so forth. So that's what a container, a Linux container is. And to actually run a container using Docker, we'll be looking at the command called docker run. So now moving to what a lot of people have come to know about containers, portability. You know, what actually makes a container portable? And a straight answer to this is it's not portable. So I always look at a container as some sort of like a moment in time where something is happening, but you cannot really just take that moment and teleport it to another place. You need some other way to capture that moment so that you are then able to take it to another place and actually make it portable. And this is where we come into the subject of container images. So container images is basically a way of taking a snapshot of a container so that you can then be able to reuse it or even share it with other people. So that's the difference between a container and an image. So an image is a lot of the times the thing that people are referring to when they're saying you can ship using Docker. It's mainly that narrative is created around containers. So now, once you've actually created the container, I mean the image, so you now have some sort of representation of your container that you can share with other people. So a container, a Docker image or a container image is actually a lot more complex than it sounds. It's not like it's not a simple snapshot, but it is actually composed of layers. And these layers are then put together, which then becomes an image. And what then happens is that if you share, if you take these layers, this image, and move it to another place, you can then run the the container from that image. But all that it will do is that it will take these layers, combine them together in some sort of like union file system, and then you end up with a container that basically represents the original container, even though it's no longer the same container. So that's what images give you. So now with images, so once you've packaged it together you are ready to share it or to deploy it to another place. Imagine that you are packaging an application. So what you can then do after that is you can take your image and you can share it with other people. And you can actually use the analogy of like photos in this instance, where an image is like a photo, but when you want to share it or to store it on the cloud so that it's accessible to other devices, you can use something like Dropbox or Google Photos or something like that. You need something similar to also share Docker images or container images. And this is where image registries come in. Basically, image registries are places where we can actually store these Docker images or these container images on the cloud. And that then allows us to be able to pull these down at a different destination or to share them with other people. And that's what really makes applications portable when developed and run using Docker. It is through this medium. which you know, there's a lot of them out there. There's one called Docker Hub. There's one called GitHub registry. There's a lot of them. AWS has one. Google Cloud Platform has one, etc. So there's a lot of different choices you can look at here. But now, so to push your image to into Docker, into a Docker registry, you simply just run Docker push, and then you specify how that image is going to look like. So, and then what you can then do is someone receiving your image can just run a command called Docker pull, which will basically pull down the image from the registry onto their machine. And then what they can do after that is run Docker run, which then derives a container from that image. So in the end, you actually end up with a Docker container which is created from the image, and that is what actually completes the portability of your application when it's built using Docker. So this is basically the basic end-to-end flow of Docker, going from a simple process that's running on the machine that's running as a container, moving into something that can be packaged and shared with other people using Docker push. And that's something you can then manage access control on the Docker registry. And then from there, other people can be able to pull that Docker image onto their machines and then create Docker containers from that image. That being said, I would just like to dive into a little bit of detail by showing you a live demo of how this all comes together. So I just want to switch to my command line. So I have an application here called it's called app, and this is just a Python application. It doesn't do anything special. It's a to-do app. So there's application.python, requirements file, and some templates with an HTML file inside. So if you want to view it as a tree, you can see it's structured in this way. So a very simple application, and this is just to illustrate some Docker concepts. So now, if I have this application, imagine that I want to develop it and end up deploying it on the server, right? So usually with these kinds of applications, you can just simply run it locally on your machine by just running python app.py. Right? But you can see here, because I haven't installed all the dependencies for this application, I will basically need to go and install these dependencies to make sure that I can then be able to run this application. But you can see there's a lot of things that are missing. And that usually is the case with setting up any application. So there is actually a different way in which you can approach this problem and try to make sure that people don't go through the same pain trying to set up your application. And that is by using Docker to run it. So to run Docker, to run your application using Docker, you simply use the command docker run. But in this case, you will see that if I just do this, it will say that it requires at least one argument. And this is because if I'm saying Docker is an engine, if I'm saying Docker run, I need to say run this, okay? And if you remember previously, we spoke about container images. This is where images come in, and this is basically what you are then able to take and say, Docker, please run this for me. Okay, so to run our application, we need to build a Docker image. And to do that, there's multiple ways to do this, but I won't go into the details of how to use each method. I'll just use the one that is used the most, and that is by creating a file inside your project called a Docker file. And I've prepared some instructions here that I will explain later if we have the time. I'm just going to save this. And then if you see my application, it now has a file called Docker file. Now, the intention of this is that I want to create a Docker image out of this application to make it easy to actually make my app portable so that I can be able to ship it. So to run this application, to build now my Docker image, I'll need to run docker build the current directory, and then I'll give it a tag. In my case, it's my username. I'll just call it app and 1.0. And then I'll hit enter. So this will build my application, and it will actually install all the dependencies that I need to run the application. And you'll see here that I have a new name for my, my Docker image. And to list all my images, I can run Docker images. And you can see that I have a new image here called excellent/app 1.0. So now that I have a Docker image, I can now actually run my, my application. And to do that, I simply need to do docker run, and then my image, just copy the name, hit enter, and this will actually run my application. And actually, we can test this over here. So I'll just hit escape on my presentation and then try localhost 500. And you see that it's not running. And there's actually a good explanation for this, and it's one of the points I'm trying to make. So Docker says here that you can simply access the application now that it's running. But this application is actually not running on my machine. It's running on my machine, but inside the Docker container. So that being said, we need a way to actually forward the traffic from my machine into the Docker container. So a different way of running this application so that it's accessible from my machine will be to use the same command, but to specify the ports. So it's the port inside the container forwarding to the port outside the container on my machine. So I'll run this again and then try to access the application. And there we go. So here's my application now, it's running. All right, so that's how you run a container. So this is now running inside the container. And then now that I have actually proven that my app is running on my local machine, I can now use Docker push to push not the container, but the image, the Docker image to the my Docker registry. So I just hit this command to do that, and it'll begin pushing my application. And once my application has been pushed, I'll actually be able to go and then download it from another machine and then be able to actually run my, my application as in a new container. So in preparation for this, what I have done is I've ordered a server of DigitalOcean, and I installed Docker inside this server. So what I want to do is, since my Docker on my local machine says that it has finished pushing the image, what I want to do is do Docker pull on this machine to get my image. So this is basically a way of deploying this, this application. So now, just like I did on my local machine, I can actually now go and do Docker run. I'll pass the port, just like I did on my local machine. And then I'll pass the image. and I'll run it. It says that it's running. So I'll just go and check on my machine, on my browser. And here is the IP address of my server. If I hit that endpoint, you can see that my application has actually been deployed. So that's basically how you can actually create a Docker container from an image, and then you ship that image into the Docker registry using Docker push. And then in your Docker registry, in another machine rather, you can then go and run Docker pull to pull that down and then be able to run that container. So in the end, you didn't ship the container, you shipped the image, and then from the image, you can then materialize more Docker containers out of that container, out of that image. And then that's how you basically ship your application. And that's how, in this case, I've managed to get my app from my development machine to my to my server. So we're not doing great on time. So I'll just like to check if anyone has any questions. So my aim is from here, so this is supposed to serve as an introduction, and the aim is to then go into the details of each of these concepts on separate talks, because already there's some things that I've alluded to, like the forwarding of ports, and I've also looked at things like, how you build a Docker image, but not with any significant detail. So I'll be hoping to then take a look at the feedback from the session and then go into the detail of each of these concepts. Do we have any questions?
Yes, I have one.
All right. Okay, so, go for it.
When we say like we don't ship a container, it means when I ship my image, I can still work on the image I have in the actual container and without affecting the image I ship. That's right.
That is absolutely correct. You can still continue doing some work on the container, on the image that is running on that is sitting on your machine. It's only when you push it and then create a container out of it that those changes actually materialize in the remote server or in the remote machine.
All right, thanks.
Thank you for that question. Do we have other questions? I remembered someone was trying to say something.
Oh yeah, I was looking for the hand icon. I can't find it. Yeah, I just needed to ask: is there a way to, like, if you wanna ensure environment stability, is there a way to roll back once you've pushed an image?
Absolutely. Yes, so absolutely. And the way that you actually do that is by creating, so let's say that you've created another image, which I can easily do by, on my machine, I can run Docker build again -t, and let me just see if I can, oh, no. So let's see. App, and then let's call it version. The first one was version 1.0, so let's call this version 1.2. And so I can actually just do a build, and because nothing changed, this will basically be the same thing. And then I can actually push it 2.0. And this should go quickly because there aren't really any changes. So what I can now do is I can go to my server, kill this container, pull the new image, pull it down, and then I can run my application again with the new image. And if I visit the application, it will still be running. But now what you can actually do is that, so if I, for instance, check Docker images, you'll see that I still have the old version 1.0, which means that I can still go back and run it as 1.0, and it'll still work just fine. So this is a way that you can actually roll back to the previous version of the image.
Yeah, thanks.
All right. Do we have any other questions?
Yes. Can I please ask something? I want to know, is it a difference between a Linux container and a container, or is it the same thing?
It's sort of the same thing in this case, because actually the container technology right now is deeply rooted in Unix, specifically Linux. So even if you are running it on Windows, there's some sort of virtualization that's happening in the background to make it run from Linux, but even though you're running it on Windows. So you can use containers on Linux, on Windows, and on Mac. Right now I'm using a Mac, and I can run Linux on Mac using containers. So it's when I'm saying Linux containers and containers, I'm generally referring to the same thing, but I do see a future where there will be a strictly Windows container or a strictly Mac container. So that will start to be ambiguous. But in this case, I'm referring to the same thing.
Okay, thank you very much.
Yeah. All right, maybe let's take the last question. All right. If not, this wraps up our session for today. I just really wanted to do a quick introduction of the technology, and hopefully to get you thinking about the possibilities that this can help you solve. So containers are not just good for portability, but also they can significantly improve your software quality, because what you package on your machine is exactly what you get on the server. So this thing of saying, it runs on my machine, but it doesn't run anywhere else, can actually be addressed by using Docker. And I hope that the next time we're doing this talk, we can actually go a little bit deeper in terms of the things that you can do, because there is so much around this concept of containers. And you've heard about Kubernetes, you've heard about so many other things. And when we do the next session, I hope to take this a step further and start looking at other concepts around Docker and around containers. Then we can slowly make our way towards more advanced uses of containers. So that's it for today. Thank you everyone for tuning in. I'll post this on YouTube for just to the benefit of those who are not able to join, but I really appreciate you taking the time for this. Thank you so much.